Danube water changed into drinkable water. Hello everyone, my name is Hari, this is Mario, this is Kaya, and we're here in Vienna, Austria, and what you have over here is the Danube Channel. We are in an urban area with a lot of traffic, as you can maybe hear in the background, cars, trams and everything else, and so you have to take an idea that this water is potentially not the purest source of drinkable water, what we can normally get from taps. And so our plan today is to do some water treatment using some traditional methods by first taking a sample from the Danube Channel, or we can call it Danube water. So now we have our sample of Danube water. As you can see, it doesn't look too bad, but what you do notice is a little bit of cloudiness. You can't see quite through it, and that's known as turbidity. And so the idea is, how can we remove the turbidity and how can we create the purest form of water that is drinkable for ourselves and safe, of course, to drink, making sure that there are no negative or reverse side effects of drinking this water. You do also notice it's a little bit difficult to see, but there are little bits of particles inside of different colors. Of course, there might be call it urban trash in the water, and that's also hopefully an aim with our water treatment to remove that and make this drinkable.
Okay, so the sample we have here, as you can see, you could think it's quite okay, but it's still somehow turbid. Like for some countries you can expect that such a water would be like drinkable or accepted by the law, but for like a Western standard we want to have a very clear, pure water of a turbidity less than 1, so it's quite transparent, quite pure. So what we are going to do is add some agents. In this case we have here iron chloride to get rid of all the turbidity, the suspended and dissolved stuff. And we are going to add iron in excess, and so flocs are going to form and precipitate out, and so the water would be like pure and pristine after the process. Okay, so my coagulant is in there, but now what I need to do is adjust my pH, because iron likes to be dissolved in acidic water, so we need to alkalinize it a bit, so iron hydroxide might form and like I get my flocs. So I will check now the pH.
Okay, so now we have most of the flocs sedimented so that we can see the reddish layer. However, there are still some flocks suspended in the solution. So what we want is to get clear water. So we have to remove the suspended flocks from the supernatant. And for this, we have to use some kind of filtration. In nature, we usually use sand filtration. So water naturally goes through the sand and all the flocks are retained by soil. However, to make it easier and in the conditions like this, we can use, for example, Brita filter. This one we got as a courtesy from the company. And with that, we just pour water inside, which goes through the activated carbon filter, and then the flocks are retained and we get clear water.
So the point of using UV is it acts as a germicide. And what we talked about before, which is the particulates that we find in water, is that they can act as carriers for microbes. And the idea that what this can do is in roughly 48 seconds with the power of this one for actually a liter, so with this size, a little bit less time, but we'll put it for the full time, we'll kill those microbes so that it becomes even safer to drink and will not mess with our internals. So I'm gonna go ahead and uncap this carefully because it is a sensitive item. Turn this on. Okay, I'm going to put this inside, and what you'll notice is that the light has turned on, the UV has activated, and this is now going to go for some time, and after that's done, it'll let us know that it's done, and then we can give this a sip. To dry off. And so what we should have now is clean enough water to drink. And I'm gonna go ahead and take a sip just to show that it does taste good and has good quality. Danube water changed into drinkable water. It's totally fine. I'm still just gonna stick with one sip.
Delicious.